All right, so this is going to be the Unit 1A assessment practice review video. All right, so what I'm going to do is just go through these problems, and if I need to show work, I'm just going to use this scrap paper I have here. All right, let's look at question number 1. Question number 1 says, which of the following is a rational number? Select all that apply. All right, so that means we need to go through all of these and see which one is rational. Okay, let's start with the first one. The first one says square root of 36. Okay, we know square root of 36 is equal to 6. Okay, we also know 6 is a whole number, right? 1, 2, 3, 4, 5, 6. All right, 6 is a whole number. The whole numbers are part of the rationals. All right, so that means 6 is rational, which means the square root of 36, which is equal to 6, is rational. Okay, so we circle that one. All right, the next one says square root of 7. Well, the square root of 7 is prime. 7 is a prime number, all right? And the square root of a prime number is irrational. So that means the square root of 7 is irrational. So we do not select this one, all right? Next option says square root of 25, okay? Square root of 25 is 5. 5 is just a regular number, okay? 1, 2, 3, 4, 5, 6. All right, it's a whole number. So we know it's going to be rational. 5 is rational, all right? Square root of 11. Well, 11 is prime, and the square root of a prime number is irrational. Okay? Square root of a prime number is irrational. 11 is a prime number, so the square root of 11 is irrational. Okay? So we do not select this one because they're asking us for rationals. All right? Square root of 12. Okay? Square root of 12 can be a little confusing because at first when you see square root of 12, you think 12 is even. Okay? So that means it has to be rational because just because it's even. All right? But for the sake of the test, we're only going to assume the numbers that are rational to be the numbers that we know about for square roots. Okay? So for example, for the test and for this problem, we're only going to assume that the square root of numbers that we know about are irrational. So square root of 1, square root of 4, square root of 9, square root of 16, square root of 36. Okay, those are the numbers that are going to be rational. In this case, we don't know the square root of 12 without using a calculator. So we're going to say it's irrational, and we're not going to select it. Okay, square root of 16 is going to be 4, and just like 5 and 6, 4 is a rational number, which means the square root of 16 is rational. And so we get F. So we get A, C, and F as our answers, and those are the ones we select. All right. This next question says, which of the following equations is correct? Select all that apply. So the best way to go about this problem is to just go through all 6 of these. All right. So let's start with the first one. The first one says 0.13 repeating is equal to 5 over 33. All right, so let's check and see if that's a true statement. Okay, 0.13 repeating equals 5 over 33. We want to see if that's a true statement. Okay, so what do we want to do first? Well, what's important here is to look at the number that's repeating. All right, the number that's repeating here is only the 3. Only the 3 is repeating. So we know we need to do the example where we have the 2 equations, the one with 100 and the one with 10. Okay, so the first step is to let x equal 0.13 repeating. Okay, then the next step is to multiply both sides by 100. So you get 100x, which is going to be 13.3 repeating. Okay, right? Because when you this 0.13 repeating looks like this: 1, 3, 3. 3, 3, right? And when you multiply this by 100, okay, you just go 1, 2, and you get 13.3 repeating. All right, so that's right here, okay? And the other equation we need is the 10x. We multiply this one by 10, and we get 1.3 repeating, okay? So now we do the subtraction. 100x minus 10x is 90x equals to, the 3 repeatings are going to cancel. Okay, and you'll get 13 minus 1, which is 12. All right, then divide both sides by 90. And the 90s will cancel. And you'll get x equals, well, the number that goes into, we need to simplify this. right? When you can simplify the test, you need to, all right? 12 over 90. Well, 3 goes into 12 4 times, and 3 goes into 90 30 times, okay? So 3 goes into 12 4 times, 3 goes into 90 30 times, okay? And now we can simplify this again, right? Because this is even over even, and when you have an even number over an even number, you can take out a 2. So you're going to get 4 divided by 2 is 2, 30 divided by 2 is 15, and you get 2 over 15 as our final answer. But they said it was equal to 5 over 33, okay? They said it was equal to 5 over 33, which is not true, okay? So we don't select that one, all right? So we do not select this one, okay? All right, let's go to letter B now. Letter B says 0.2 repeating is equal to 1/5. All right, let's see and check if that's true. All right, so 0.2 repeating. 0.2 repeating equals 1/5. We want to see if that's true, okay? So the first thing we're going to do is let x be equal to 0.2 repeating, okay? Then we need to do, we need to look at the number that's repeating. In this case, there's only one number repeating, okay? It's going to be 0.22222. So we only need to multiply this one by 10, okay? We only need one equation here. So we're just going to do 10x, which is going to be equal to, when you multiply this by 10, right, you just get 2.22222. So you're going to get 2.2 repeating minus the original equation, x equals 0.2 repeating. Subtract those from each other. 10x minus 1x is 9x equals to 2 because the two repeatings cancel. And then we divide both sides by 9. And we get x equals 2 over 9 as your final answer, okay? But they said it was 1/5, and we got 2 over 9, okay? 2 over 9 is not equal to 1/5, so we don't select that one, okay? It's not equal to 1/5, so we do not select that one. All right, so we can cross this one off too. All right, let's go to the next one. The next one says 0.45 equals 5 over 11. All right, 0.45 repeating equals 5 over 11. All right, so 0.45 repeating equals 5 over 11. Okay, so notice the 4 and the 5 are repeating here, or what's repeating? 0.454545. Okay, when this happens, when you have two numbers that are repeating, you only need one equation. But the one equation that you need is the one with where you multiply the original equation, which is this one, x equals 0.45 repeating. We just need to multiply it by 100. So we get 100x equals, when we multiply this by 100, you get 45.45 repeating, right? Because when you move it over, you still get the 45, 45, 45, okay? So you get 100x equals 45.45 repeating. Subtract off the x. 100x minus 1x is 99x equals to, the 45 repeatings will cancel. You'll get 45. Divide both sides by 99 to get rid of get the x by itself. And you'll get x equals 45 over 99, which can be simplified. Okay, it can be simplified. So we'll do, I'm going to use the greatest common divisor so that I only have to do it one time. So I'm going to use 9. Okay, I know 9 goes into 45 5 times. And I know 9 goes into 99 11 times. Okay, so I get 5 over 11. All right, if you forgot what the greatest common divisor means, it means you take the biggest number that goes into both of them. Okay, so you could have done this using the 3's trick, right? You could have said, well, 3 goes into 45, right? Because 4 plus 5 is 9, and 3 goes into 9. That means 3 goes into 45. And 9 plus 9 is 18. And 3 goes into 18. That means 3 goes into 99. Okay, so what you could have done was divided these by each one by 3. Okay, so 3 goes into 45 15 times. 3 goes into 99 33 times. But now what you can do here is you can use the 3's trick again. 3 goes into 15 5 times. 3 goes into 33 11 times. So you get 5 over 11 just like you did down here. Okay, so whichever one you like to use more, you can do. All right, so we get 5 over 11. The problem says 5 over 11, so we know these are equal. Okay, so we can select that one as one of our answers, which is going to be letter C in this case. So we'll circle C, or we'll check the box on the computer, whatever it is. All right. The next one says 0.5 repeating is equal to 5 over 9. All right, let's check that one real quick. All right. So we know there's only one number repeating here, it's the 5. Okay, so we get 0.5 repeating equals 5 over 9. Okay, 0.5 repeating, so it's only one number that's repeating. So we just need to multiply by 10. Okay, so we'll do let x equals 0.5 repeating. Then we'll multiply both sides by 10, so we'll get 10x equals 5.5 repeating. Okay, and now we can subtract these from each other, right? Because when you multiply this one by 10, right, it's 0.555. When you multiply by 10, you just move it once over. So you get 5.5 repeating, okay, which is right here. All right, so now we'll subtract, and we'll get 10x minus 1x, which is going to be 9x, equals to, the 5 repeatings will cancel, and you'll get 5, and divide both sides by 9, and you'll get x equals 5 over 9, which it says up here, right? So we know these are equal, and that means we can select that. We can select letter D as our answer also. Okay. The next one is going to be 0.16 repeating. We want to see if that's equal to 1 over 6. Okay, so let's see. So it's 0.16 repeating. All right, so we're going to have 0.16 repeating equal to 1 over 6. We want to see if that's a true statement. Two numbers are repeating, so we only need one equation, all right, which is going to be the one with 100 because it's two numbers, all right? And because the bar is over both of them, we only need one equation, all right? So let's see. Let x equal 0.16 repeating, which looks like this, 0.161616, right? We'll multiply both sides by 100. We'll get 100x equals 16.16. Subtract off the original equation. And then 100x minus 1x, 99x, equals, the 16 repeatings will cancel. You'll get 16 divided by 99. All right, 99s will cancel. You'll get x equals 16 over 99. And if you look at the threes trick real quick, 1 plus 6 is 7. 3 does not go into 7. That means 3 does not go into 16 evenly. Okay. 9 plus 9 is 18. Okay, so 3 goes into 18. So that means 3 will go into 99. But don't forget, the number that you take out has to be the same as both the numbers. Okay? So the number that you take out has to be able to be taken out from both of them. So you can't just take out 3 from the bottom. You have to be able to take out 3 from the top and bottom, which you cannot do here. Okay? So our answer is going to be 16 over 99. But they said it was 1/6, 1 over 6. Right? That is not 1/6. Okay? So we do not select that one as our answer. All right? And the last one here is going to be 0.93 repeating, which is going to be equal to, they're saying it's equal to 43 over 45. So real quick, we can cross this off. And we'll have the next one says 0.93 repeating equals 43 over 45. So what I can do here is I can multiply. Well, let's see first. Let's let x equal 0.93. Okay, only the 3 here is repeating. All right, so when it's only the 3 repeating and it's 2 digits, you know it's the one where you need 2 equations. Okay, so we're going to do 100x equals, when you multiply this by 100, you're going to get 93.3 repeating, right? Because it looks like this. And when you move it twice, you get 93.3 repeating. Minus the other one we need is 10x. Okay, and when you only go once, you get 9.3333. So you're going to get this equal to 9.3 repeating. Okay, 100x minus 10x is going to be 90x equals, the 3 repeatings will cancel. 93 minus 9 is going to be 84. Divide both sides by 90. You'll get x equals 84 over 90. Now it would be a good time to simplify this. All right. I'm gonna simplify with the twos trick, maybe because it's just the twos because they're both even. Okay, just to make them a little bit smaller. So 2 goes into 84 42 times. 2 goes into 90 45 times. Okay, and as you can see, they said it was 43 over 45, but what I just got is 42 over 45. Okay, 42 over 45 is not equal to 43 over 45. Okay, so we do not select this one. Okay, so that's another one we cross off the list. All right, we crossed this one out also. All right, so the only answers we chose here were C and D. Okay, the next question, number 3 says, does the number whatever have a decimal expansion? Okay, and whatever that question says, whatever they put in for this number, okay, it doesn't matter. All right, whatever this number is, it has a decimal expansion. Okay, so decimal expansion is going to be, we know every number has a decimal expansion. That's something you need to know for the test. Is every number has a decimal expansion. Okay, that's something you need to know for the test. Every number has a decimal expansion. All right, so no matter what they put here, all right, every number has a decimal expansion no matter what. Okay.